All right, so let's kickstart the discussion. Before we go into today's topic, just want to do like an overview of what we did in the last lecture since it was two weeks ago. So last lecture, we really focus on, first of all, understanding what's a company, the structure. We talk about agency problem, which is something that I highlighted was quite important, right? Remember agency issues. It's important to understand how it works, what's the mechanism, what can be done to reduce agency as well. Then we move on to more details on like the balance sheet, the P&L, and I understand some of your accounting majors, while also a lot of you are not. So it could be also the first time seeing like a financial statement. It can be quite daunting. However, do not worry because we went into more detail on like the ratio analysis. And what's important is that I think if you look at the slides, I also provided a kind of sample analysis of a company. So that is really important to look at. Whenever you do a ratio analysis, use that as a reference because it provides you background on how you actually describe certain ratios, what's the language you have to use, and all. Right. So that's what we did last week. Any concerns, any questions, feedback so far that you'd like to raise before we start lecture 2? I'm just posting the password for everybody in case you need the password. All right, so I guess we are good so far. So let's think about the structure of today's lecture. So as usual, I hope that's fine. We do 2 breaks, 1 every hour, so that we can all have a rest as well, because sometimes it can be a bit heavy. And today lecture, the structure of it will be this. So in our T07 group, you'll see 2 sets of lecture notes, right? However, we'll only go through the first set of lecture notes, and the first set of lecture notes covers all the information in terms of examples, not really examples, but in terms of all the theory and the calculations, how to do certain calculations for lecture 2. Now, how I structure it, which is slightly different from the other classes, is that the second set of notes has a combination of all the questions that we are supposed to go through, right? So usually I prefer to not rush through the questions, the examples, meaning examples relating to the theory that we're going to learn, right? So what will happen is that I've done a pre-recorded lecture for lecture 2B, right? For the second set of notes. So after this lecture, during the week, you have some time, we have to go through the second, or even next week, because now our lectures after the week. So even next week, you can go through the lecture 2B recording with the second set of notes. And that set of notes basically is questions, it's purely questions of what we're going to cover today, right? It will be even better if you could practice the questions first, then walk through the lecture. And if you notice in lecture 2B notes, all the solutions are provided, workout solutions, step-by-step solutions, etc. So it's really more of just consolidating all questions in one set of notes and consolidating all the theory and calculations that we have to learn in this set of notes that we're going through in the live lecture now. Okay, so there are 2 sets of notes. If you go to your module in T07, if you scroll down to the lecture slides under those that I have edited, you'll see that in the second unit, there is 2A and 2B. So there are 2 sets of slides, right? So in this lecture now, we are only going through the first set, which is called 2A. And then the 2B, you have to go through it on your own. Yeah, you have to go through your own by looking through the recorded lecture. And how I have categorized it is that for 2B, is all questions only, so practice questions. And 2A is all the theory that we have to understand, we need to know, and if you have any questions, we'll have discussion now, right, on lecture 2A slides. So the pre-recorded lecture for 2B has already uploaded as of now. So you can actually do it later, not later, but it's quite late already, but I mean like tomorrow or the next week. Okay. Okay, so let's let me just see. Let's put this. Give me a moment. Okay. All right. So before we dive into detail about what are we covering today, right? As usual, I'd like to give a broad overview of what is the concept in layman terms, right? So in layman terms, right, what we're trying to do today, like later you'll go to a lot of detail, but just in layman terms, what we're trying to do today is money. If you have a sum of money, and the money is in different periods, meaning different time, whether you have the money now or whether you have the money 1 year later or 2 years later, this same amount of money, let's say $100, is worth different amount when the period changes, right? So, for example, if the money you receive now that means like now, is different from the value of this money is different from the money you receive, let's say 2 years later or 3 years later, the same $100 you receive 3 years later, it has different value in finance, right? So at the end of the day, that's what we're trying to do here in finance. Or in this lecture 2, the overview or the idea is that this money is worth different amount. It's valued at different amount, even though it might be $100, but if it's a different time period, if it's now, 2 years later, 1 year later, it's worth different amount, right? So I hope that you can understand that whatever calculations that we do is just based on this very simple concept. And the reason behind it, okay, so now it's more finance, right? So the reason behind why this sum of money is worth different, even though it's just $100 today, $100 in 3 years, is that because in finance, there is this thing called opportunity cost. Okay, so what does this mean, opportunity cost? It means that if you receive the money now, $100 now, you can use this money to invest in something, right? You can put it in stocks, you can put it in fixed deposit, etc. And when you do that, this money, $100 now that you receive now, can earn some interest for you. However, if you receive the money 2 years later, you can only use the money 2 years later to start investing. Any questions on this? This is just overview of what we're trying to do today. And we'll go into a lot of calculations after this. And we're of course going into details as well. Any questions regarding this? Just a concept in the most, hopefully the most simple terms, right? That's what we're trying to do. To calculate, so in this lecture, there's a lot of calculation. So what we're trying to do is to calculate this same sum of money as it moves from different period, right? Because it works different amount. Okay, so okay, so that's good. There's no question. So let's dive straight into today's lecture. Okay, so in finance, or from this lecture onwards, and for the rest of this course, there is this concept called simple interest versus compound interest. Okay, and simple interest is something that, or the compound interest is probably something that you have seen before, right? So simple interest means that this interest earned only on the original sum. So what does this mean? So let's say you have $100 and you save it for 2 years. So how much will you have after 2 years if the interest rate is 10%, right? So for simple interest example, you just take $100 times 10% times 2, right? Because you do it for 2 years. Then you plus back your principal. So this is what you get at the end of 2 years, $120. Okay. Now, in compound interest, your interest is earned on both the original investment and on the interest as well. So this is where you have your square already. So what does this mean? Compound interest is you take the $100 times 1 plus 10%, so 1.1 square, right? Square meaning that you take the interest for the second year on the interest, basically interest on the interest, right? So if you see the compound interest, you have slightly more 1 to 1. The $1 because you are getting interest on the interest that you earn. So in finance and in this module, we only use compound interest, right? So we only use this. So after this, like you'll never see simple interest anymore. So our focus is only on compound interest, and regardless of any questions, if they did not say whether it's compound or simple interest, it's always compound interest, unless the question say, okay, they have a special case where it's a simple interest. Then okay, then you use simple interest. Now let's have a simple example here. Okay, to show the power of compounding. So suppose you have a great grandmother that deposited $10 only. Okay, so $10 for you at 5% for 200 years, right? How much would you invest? Would the investment be worth today, right? For 200 years, quite long. So you have this $10 times 1.05, 1.05 because it's 5% here, right? And to the power of 200, right? Because it's put for 200 years. And you can see, wow, actually this $10 is worth 172,000 or 170, almost 73,000, which is quite a lot of money, right? However, if it's a simple interest, what happens? You just take $10 times 5% times 200 years, right? You only get $100. So this really shows the difference between compound interest and simple interest as the number of years increase. So compounding actually adds so much more interest into your investment. So this is a graph showing you that as the number of years increase, the value of your investment increase dramatically if it's a compound interest. All right. So this is I want to highlight, this is a very important slide. And let's understand what is it trying to say. All right. So we invest again $100 for 10% for 2 years. Right. Now we are tackling this thing called compounding period. So what's the period of compounding? So what's happening here? Now, in the last two example that we talk about is always annual compounding. Annual compounding means the interest is compounded or if you want to use a simple term for compounded, it is being recognized once a year, right? Annually. So this is what we have done earlier. Now, it could be a semi-annual compounding. Semi-annual means what? Every 6 months, you will determine or recognize the interest. Okay, so how do you actually do it? If it's a semi-annual case, you will have to reduce, of course, the interest rate by half, right? Because originally it's 10% per annum. Now if you use semi-annual, you must reduce it by half. That's why it's 2. However, the number of compounding period has doubled, right? Because it's semi-annual. Because previously, for 2 years, how many? So for annual, for 2 years, they have 2 periods. But for semi-annual, for 2 years, you now have 4 periods, right? Because it's 4 times. You recognize interest 4 times in the 2 years, right? Because it's semi-annual. So similarly for monthly, what is happening here? You divide by 12, right? Now, the number of periods that you have is now 12 times 2 because you recognize the interest every month, January, February, March, April, etc. for 2 years. So it's 12 times 2. So number of compounding periods comes to 4. If it's daily compounding, same thing, you divide by 360 because the rate is being reduced. And it's for 2 years, so 365, sorry, divide by 365. And then for number of periods, it's 365 times 2. Okay, do not worry about this. We'll not talk about continuous compounding, but I'll just put the formula here. Okay. Because we will not use this idea of continuous compounding in this module. All right, so what you have seen earlier, we can actually put this into almost into like a formula for the let me just highlight this part, the red portion here, right? This why you divide by 2 and all. So there is a proper way to actually describe it. So there's this thing called annual percentage rate, APR. APR equals to the nominal rate. So APR and nominal is the same, right? It's the same meaning. Now, what is this rate? So this rate is the rate that's quoted by law or quoted, let's say in the, if you take a loan, it's quoted in the loan documents, right? It's quoted by law. So the APR, when you take APR, divide by number of periods, we will get the, what's happening here? We will get the periodic rate, right? So, okay. See, okay. It's all right. I think you saw it. So you have your slides in front of you. So when you take the APR, divide by number of periods, you actually get the period or periodic rate. So what does this mean? So it's actually what we have been doing here, right? Take 10% divided by 12, 10% divided by 360. So 10% is a nominal or the APR. You divide by number of periods to get the periodic rate. So because it's daily compounding, that's why we need to calculate the periodic rate. So let's see what happens here. So what is the APR or nominal rate if monthly rate is 0.5%? Right? So now, remember, your secondary school, you do the X-Men. I'm not sure whether you learn it this way, but remember APR divided by number of periods, it gives you the period rate, right? Period rate. So you do the X-Men like this, meaning you just take number of periods times the period rate. This is the period rate, right? P rate. So you multiply it and you get the APR here, right? Annual percentage rate or nominal rate. So if it's a semi-annual compounding, you just multiply by 2 because using this formula, multiply by 2, you get the nominal rate. Now, what is the monthly compounding if the APR is 12%? What's the monthly rate if the APR is 12% with monthly compounding? So now we are finding what is the monthly rate or periodic rate. So now we just take APR divided by 12, which is this formula here, right? APR divided by 12, get 1%. Now, this is an important conceptual question below. So can you divide the above meaning this one, by 2 to get the semi-annual rate? So at this point, I want to highlight to you that no, you cannot do that. Why? So the APR that you have calculated here, the APR of 12%, is based on monthly compounding, right? So if you want to find the semi-annual rate, which is a period rate, you need to get an APR based on semi-annual compounding. Then you can calculate what is the period rate or semi-annual compounding. Okay. In other words, okay, to re-explain this again, your APR, let's say your APR of 12% is unique to the compounding. So this APR of 12% is unique to a monthly compounding type of product, okay, financial product, right? It's unique to monthly compounding product. So if you change the compounding period, your APR will change. So you cannot say, okay, because I have an APR of 12% for monthly compounding, can I calculate a semi-annual? Because no, because if you are calculating semi-annual, this is based on semi-annual compounding, right? So your APR is tagged or it's matched with the type of compounding. This is an important concept. Everyone get this?
Prof. Raja here. Sorry, can I? So can I check? Does that mean your second bullet, right? your second bullet
Mhm.
says if the semi-annual rate is 0.5%. Would that
Yes.
would can we use that? So let's say the answer is 1%, right? And then you say, can you
Mm.
divide the APR by 2 to get the semi-annual rate? Can I say that then I'm dividing the 1% by 2 and then getting 0.5 if I because that was based on semi-annual rate?
Yes,
Would-
you can. Yeah, that's totally correct. You are right. Yes. I think you understand it. Yes, that's perfect. Yeah.
Right.
So,
Okay.
yeah, that's right. Yeah,
Okay.
because this APR now is based on semi-annual. So to repeat for everyone's benefit is Raja was asking for this question here, right? Can I use this value here? Because this APR of 1% is based, so this APR of 1% here, which you have calculated, is based on semi-annual. So if I want to find what's the semi-annual rate, yes, in this case, because it's based on semi-annual, you can just divide by 2 to answer this question here. Yeah, perfect. Okay. Okay, so that's for APR. Now let's think about a little differently. This thing called effective annual rate. So what's this effective annual rate? So effective annual rate is this formula. Okay, so the idea, let's think about idea first before we look at the formula. Idea is that, okay, you have let's say you have two investments, right? With different type of compounding. One is annual, one is semi-annual. Now, the question people was thinking about, like, oh, okay, if that's the case, how do I compare these two products, right? Because one is annual, one is semi-annual compounding. So that's where there's effective annual rate comes in. Basically, you force or not really force, but you recalculate the rate as if it's only compounded once in the year, as if it's only compounded once in a year. And then you can compare the product, right? The product with semi-annual versus annual. So that's the idea behind effective annual rate. Okay, so which is actually what is explained here to compare investments in different compounding periods. So you have this looks very difficult formula, but I will not worry too much. You can use this formula. So what's this formula trying to say? I'll explain to you in case for those that want to use a formula, but don't worry, we can use Excel as well. And I'll show you the Excel method, which is really simple, right? However, for those that want to use the formula, you can do this, right? You put the nominal rate divided by n, which is a number of compounding periods, right? So if it's a semi-annual compounding, means you put 2, right? Semi-annual means 2. Okay, so semi-annual, this example, semi-annual, you put 2 here, put another 2 and minus 1, and this is the effective rate. So once you get the effective annual rate, you can compare this product based on semi-annual with a product that is annual compounding. Okay, so we have an example. Let's have a look at example so you make it more clear. So this example here, so which account should you choose? 5.25% daily compounding, or 5.30 semi-annual compounding. So the workings are already there, but I would like to just pull up Excel. If you have Excel in front of you, do follow me so that you can actually practice how to type, because sometimes when you practice how to type, it can be quite different. You might find some difficulties, so you can answer them in the class. So if you do have Excel, do it. Try to practice. Let's see. Let me try share my screen. Okay, so I'm sharing my Excel screen now to show you what to do. So you have the question in front of you, right? Okay, so let's see. Now we can use this thing called EFF. So if you have Excel, try to follow me here. So you have this thing called EFF. Let me just open the chat. Okay, so EFF ECT is effective rate. So they ask you what's the nominal, what is the nominal rate, and what is the NPERY, meaning what's the number of periods. So in this question, we are given the nominal rate at 5.25%, meaning that 0.0525. Oops, 0.052. Okay, so at this point of time, I want to highlight that in Excel, it's very important you put it in decimal. The percentage is in decimal. So don't put the percentage because they say the question is 5.25%, right? But you put in decimal is 0.0525. So this is important because I think sometimes if you forget and then you put the decimal 5.25, you'll get very, of course, wrong answers, right? So now going on to the NPERY, we put the question say 365, right? So this is in decimal, we can convert into percentages. So you get this. I'm just going to do the other one as well. If you have Excel, you can do it too. So the other product is 0.053, right? And it's a semi-annual compound, semi-annual, so two types, going to compound two types. So this is the number which you get. And you can compare. So which saving account should you choose? Anyone? Which one is better? The first one. Yeah, that's right. The first one is better. And we can do this because we have calculated the effective annual rate. Okay, let me just reshare my screen. And okay, so we have our question here. Now let's move on to the next part. So now that we know how to compare two investments with different compounding period, there is this idea called the rule of 72. So what's this rule trying to say? So this rule is an approximation, right? So this rule is an approximation, meaning what? If a question asks you about how do you double the money, please read the question carefully. Is it asking to estimate? So the word, if there's a word called estimate, approximate, then you use this rule of 72, right? If the question did not say calculate. So if you use when the question say calculate, you cannot use this rule. So this rule is approximate. So approx, right? So it's only approximation. So this is important. It's only approximation. Huh? Now, so what's this rule trying to say? So the number of years to double amount of this investor is given by a certain interest rate based on this 72 rule, right? So let's say you want to double an amount of money, you just take 72, divide by the interest rate of the product that you have. So in this case, if the product is 12%, give you 12%, the rule of 72 says that you take 72 divided by 12, means that it takes 6 years to double your money. That's how you do it. Or the other way around is you want to double the money in 5 years. So what's the percentage of returns you have to get? You need to take 72 divided by 5 years, means that your investment product must have 14.5 percent return. Again, I'll highlight this is approximation. So please read the question carefully. If the question is asking for approximation, use this rule. We use this rule. If they ask you to calculate, then you have to calculate normally.
Sir, sorry to interrupt. Just wondering, right? If these interest rates, I presume, are annual interest rate. Am I right to say that? So it's
yes.
I'm just trying to understand. So like the previous slide, when you mean 5.25, does it mean 5.25% daily, or does it still mean 5.25 annually, but with a daily compounding?
So it's the second one, 5.25 annually with a daily compounding. So these rates are the APR. So that's a good question. These are APR rates, annual percentage rate or nominal rates at
Okay,
a
so
daily compound.
but you're saying the APR we calculate, like in this case, should be 5.25 divided by 365, right? Because it's over the period.
No, the 5.25 divided by 365, that is your periodic rate.
Oh, that'll be the periodic rate. Okay.
Yeah.
Right. Okay. So
This is
most of these questions, these interest rates are actually they are your annual interest rates. It's just a matter of how frequent is the compounding, how the compounding is calculated based on. Okay. So would I be
so
right to say the rule of 72 is based on annual compounding?
the rule of 72, yes, is based on annual compounding. You're right. Yeah.
Right. Okay. Okay. Can. Thank you.
Yeah. So to repeat, that rule of 72 assumes an annual compounding cycle, right? So if the question is a bit more tricky, they try to say, oh, I want it in semi-annual, then you need to do some conversion already, right? So you need to do some conversion in terms of the rates, eventually, the returns that you get here. Okay. So for everyone's benefit, just want to repeat and highlight again the question. So the question is 5.25, which is given here, period rate or nominal or APR rate. So let's just use a nominal rate, okay? The term nominal. So is this nominal or is it period rate? So this is always nominal. And when you take 5.25% divided by 365, this is now the period rate that is given in the formula previously, right? So in all questions, they always give you the nominal rate unless otherwise stated, right? So if they just say the investment is 5.25% with at daily compounding or monthly compounding, it assumes it's nominal rate. Okay, thanks for the question. That's a good question. Now let's put rate aside. Let's think about this thing called future value now. Recall that we mentioned at the start of the lecture, right? What's the purpose or what's the simple terms of this entire lecture 2 and why are we studying this? Is that money in different points of time is worth different amount, right? $100 received now is worth different from $100 received 2 years later. And that's the idea of this thing called future value. So what is the future value of $100 if for 3 years at 4% return? So this, of course, this 4% is your nominal, right? Nominal rate. And it's assumed. So as mentioned, we will never use simple interest anymore. We always only use compound interest. So what happens is you just compound it 3 times, right? Use the compound interest formula, this one. You can do it step by step like this, period 1, 2, 3, or you can just use the compound interest formula. And this is a formula that you can see here. So future value, FV, equals to the present value. So what's the value now? Present value, which is $100, times the number, times 1 plus the rate. So it's 4%, 1 plus 4%, and the number of times you want to compound it. And it's for 3 years. So the T equals to 3. We have a question here as well. So let's see what's this. So you have this guy, Peter, who bought Manhattan Island for $24, very cheap, in 1626. It's quite a while back. And what is happening? Calculate the future value of $24 if it was invested for 393 years. Okay, 2019 minus 1626, at an interest rate of 10% per year. So this annual compounding. So we can use the formula, the FV formula that we have put. So you know the present value, you bought it in 1626 at $24. Okay. You know the interest rate, 1 plus 10%, and the number of and T, number of period, is 393. Okay, so at this point, I'm just going to toggle over to my Excel because I want to show you also you can do it in Excel, so you don't need the formula at all, right? So if you have Excel, try this with me. So let's go to Excel. We have this thing called FV. Okay, so it pulls out this function here, FV. Okay, let's try what. So there's a few things that's happening here. So it's asking you what is the rate. And when they ask rate is the nominal rate. So what's the rate given here? So the rate is 10%. So remember in Excel, you must put in percentages. Put in decimals, not percentages. So 0.1. The number of periods, NPR, so number of periods is 393. PMT is called payment. Now let's just put it as 0 first because we'll tackle this component later because there's no payment here. Put it as 0. What is the present value, PV? So present value is 24 as given in the question. Last but not least, type, you put as 0. We'll tackle this later as well. And you should get this answer here. Now, there is a negative sign here. Don't worry. It's actually wrong, but we'll in the next slide we'll go through what should be done. Okay. Because that working is a bit wrong. So if you wrote that down, please take note. It's a bit wrong, but I want to explain why there's a negative there in the next slide. Okay. All right. So now we go to this part on timing of cash flow and what does it mean? What the conventions, right? So the conventions is that when we draw a timeline, we always start with year 0. So year 0 means is now, is today, right? Year
Sorry,
1 is,
Raja
yeah.
here again. Sorry to interrupt. This just came to mind. The when we're talking about the future value, right? So does that always assume an annual compounding rate, or is there something that can get more complicated? Because this seems to be the formula that you mentioned. Does it always assume that it's going to be an annual compounding rate, or can it be a semi-annual compounding rate that's a future value that's 2 years later?
So that's a good question. So yes, it can be semi-annual, it can be daily, and then you need to change certain parts. Let me just quickly see whether we have a question on that. I know we have a question in lecture 2B, but then okay, that's a good question. Let's tackle the question here in this form. That's a great question. So the question is, let's say if it's so in this question they say per year, right? So per year is annual compounding. So it's very clear. Okay. This is definitely annual compounding. Now, if I change the question to monthly compounding. So 10% interest rate of 10% with monthly, okay, I will not spell fully, compounding, right? So you know this with monthly compounding. So what's happening now? Okay, so what must you do? Okay, so I'm just going to focus on the Excel method, so we'll not use the formula. So if you have Excel, can follow me on Excel. Now, but I'll just write the formula on the Excel inputs here. Okay. So what is the rate now? So rate R in Excel. So this is 10% with monthly compounding. So the trick, whenever we have different, okay, so let me repeat again. This question is giving 10% with monthly compounding, but you know 10% is annual, right? Is the nominal rate. But we now need to do what? We need to calculate the period rate. Okay, so I'm just going to flip over back to the slides here. Remember this? Remember this? We need to calculate the period rate. So we need to do this now. Okay. So I'm going to go back to the question. Yes, you're right. I see 10% divided by 12. That's correct. So what do we do here? We need to take 10% divided by 12. All right. Remember in Excel, you have to put in decimal. What else? What else required in Excel? NPR, NPER equals to number of periods. What's the number of periods now? It is you need to also multiply the number of periods by 393 times 12, right? So because the number of periods has increased. Yes, perfect. Yeah, right. So you have to do times 12. Now, what is the PMT? PMT as is still 0. There's no payment periods. And we'll talk about payment periods in a bit. What's the PV? PV equals to 24. Right? I'll put a negative here because the correct answer is negative 24. But we'll tackle that in the next slide. Why is it negative? So it's actually negative 24. If you punch this in your Excel, you should get the answer as well. So that's a good question. If it's monthly, you need to do adjustments to your calculation like this. Like this. Yes, and the second set, lecture 2B, the pre-recorded lecture, we'll go through a lot of the questions and they'll have some tricky questions like this as well. So it's important to go through that one after today's lecture. Okay. All right, so we are talking about the periods. Today is year 0, and then 1 year later for today is year 1. Okay. Now, convention. So these are conventions. Next, the convention about cash flow sign. Okay, so the way I like to teach it is very simple. When you look at a question, always imagine money flowing in or out of your pocket. So your own pocket. So regardless of question, always think about, is it money coming in or coming out of my pocket? So what does this mean? It means that if the money is going out of my pocket, it is going to be a negative sign. If it's coming into my pocket, it's going to be a positive sign. So going back to the previous question about Manhattan Island. Okay, in 1626, I'm going to buy Manhattan Island. Is money going in or out of my pocket? Out. Perfect. So it's a negative, right? That's why I mentioned that this thing should be negative 24. Now, let's think about it as well. The future value that you calculated in Excel or this formula, you will actually get a positive number. So what is happening? So it means that actually this is money going in my pocket, right? Because now my investments in 2019, I can actually sell the Manhattan Island and getting money in my pocket. So that's why it's positive. So you can do a check whether it's positive or negative, right? So this is important to make sure your convention is correct, because when you do certain calculations, when you calculate R, so later we'll learn how to calculate R. When you calculate R, we need to make sure convention is done properly. If not, your R number will be wrong. Okay. So in always the trick is imagine your pocket. Is it going in or is it going out? Okay. More ways to solve FV. I want to highlight that I think some of you did email me about this financial calculator. You might use it in some other modules. However, in this module, we will focus on purely on Excel. So this is the only method we are going to focus on. Financial table, we stopped using it already, right? Financial calculator, if you do have questions and you want to still use it, do not hesitate, reach out to me, because I used to actually teach this module using financial calculator. However, the school's stand is that we would only focus on Excel moving forward from 2 years ago. So we just use Excel for now. Okay. So we have done the FV function. I will not repeat this again. I'll skip the financial table. This is just for you to know that this thing exists, but we'll not cover it. you will not be forced to use this. Everything can be done in Excel. And so we move on to the next part called present value. And present value basically is I would say almost like the opposite of future value, right? So recall future value is what is the value of this $100 2 years later. However, present value is the idea that, okay, if you are being given $200 or let's put $100 2 years later. So that means you are going to get this $100 only in, now it's 2024, right? 2026. $100. You're given $100. So what is this $100 worth now? Now meaning in 2024. So that is where present value comes in, right? What's the present value of this $100? So if you notice the formula is kind of like just shifting the formula around. But don't worry, this probably the last time you see a formula because we always use Excel in this case for present value as well. If the interest rate is positive, your present value is always less than future value. Why? It's because by looking at the formula, you can tell that your present value is future divided by something, right? Something, the rate or whatever. So this rate will, of course, reduce your future value. It will reduce it here. Okay, we have a question to have a look at this. So how much is 103 to be received next year worth today if interest rate is 3%? So we are going to use the formula first. The formula, you just put your, so this is your future value now. So this is your FV, right? So you put your future value, you put your rate, and it's 1 year, right? 1. So this is, if using a formula, you can get this. Now, second question, if you bought a new computer for 3,000, the payment is due in 2 years. You can earn 8% of your money. How much money should you set aside today in order to make the payment due in 2 years? Okay, so now I'm just going to toggle back to Excel. I want to show you how to do it in Excel. So if you have Excel, try to follow me on this. Okay, we have. Now, let's pull out the PV formula here. So use PV. So this PV here. Okay, now let's look. What is the rate? So the rate, the question is 8%, so 0.08. Remember, always put in decimal. Now, number of periods, we have 2, right? The payment is due in 2 years. So it's 2. Number of periods is 2. Payment, let's put it as 0 as well. We'll talk about this later. And now, what's the FV? Anyone would like to try? What is that amount that you should put in FV? Okay, 3,000. Now, let's think about it. Is it supposed to be a positive 3,000 or negative 3,000? Is it money going in or out of your pocket? Negative, that's right, going out. Because at 2 years, you need to pay, right? Going out of your pocket. So let's put negative 3,000 here. So it's important to always consider the sign. And this is the amount that you have to set aside. So this is the amount that is going into your pocket now. And then 3,000 is going out of your pocket. That's why it's negative later. Okay. Any questions so far? We are good. Okay, we have one more example here. Suppose you want to borrow 200K pesos for 1 year. Interest rate is 12%. You and your lender agree that the interest on the loan will be 12% times 200K equals to 24K. So the lender deducts this interest amount from the loan upfront and gives you 176K. Anyone can figure out why is this wrong? It makes sense, right? You might as well just pay the interest immediately. I just give you 176K instead of the full amount. So what's wrong here? So yeah, it's almost like using simple interest, right? However, better to do that, right? Better to do that. Lender is losing money. Okay, I think you're getting there, but let's think about it. Yeah, actually you're right. The lender is losing some money. Okay, so what's happening here? Instead of paying the interest 1 year later, you're paying straight away now. Yeah, you cannot deduct because remember what we talked about. The whole idea of this lecture too, right, is to say that money is worth different amount at different period of time. So if you're going to take away 24K now, the idea, before even calculating, the idea is that the bank that is doing this is actually taking more money from you, more than 24K, because money is worth less in the future and worth more now. Okay, before doing the calculation, this is just explanation. Now let's prove to yourself that it's the right thing. So what's wrong here? So how do you calculate the rate? So the rate of the this loan now. So the interest is 24K divided by 176,000, right? So if you punch your calculator, you should get something around, I think it's around 13%. There's about, so the banks are charging you a lot more. Now, rather than doing this, I want to use Excel now, right? Because I really like Excel. I don't want to use any manual calculation. So let's try to use this in Excel. So pull out your Excel. Now let's use this function called rate. So pull out your rate function here. Okay, so please follow me if you have your Excel. Number of periods, we know that it's for 1 year. Let's put 1. Payment, let's just put at 0, because we'll talk about payment later. Now, what's the present value? Anyone can share what's the present value? Remember about your sign, positive or negative. So what's the present value here? Positive, you're right. And what is your future? Wait. Is it 200? No. Wait, your present value is not. Remember? No, it's not 200. It is 176,000. Yes, correct. Because the bank is not going to pay 200. It's just going to straight away deduct 24K, right? So you're only getting this. Now, what is your future value now? What do you have to pay back the bank in 1 year? No, you don't pay back that amount. What do you have to pay back? Okay, but is it a positive or negative now in this case? Negative. Yes, that's right. So always remember the negative. And this is what you get, around 13.6%. So you know what? Let's just prove to yourself, right? If we change this negative and positive, oh, it still gets the same answer. Okay, not too bad. So it does not affect so much the rate function, but we should do it properly because it affects some other functions. Okay, so what is happening here? You calculated 13.6%. So the bank says it's only charging you 12%, but in actual fact, because money is worth different amount in different period of time, and it's worth more now, as in year zero, that's why the percentage you calculate, the actual loan amount that you calculate is more than 12%. Okay, I'm just going to stop sharing. I'm going to switch back. You will notice I'll be switching back and forth quite a bit because we have Excel, and I'd like to show you how to use the Excel. Because for your TMA, even for your finals, you need to be able to use the Excel to late. All right, so everyone got this. So remember to put the convention correctly. Positive 176K and negative 200K for future bet. Now, there are some basic kind of definition for this thing called R that we have calculated earlier in the question. You'll see different questions calling it different things. Discount rate, cost of capital, opportunity cost, required return. So they're all like different names, but they mean the same thing. It's the interest rate. Okay. So terminology depends on the usage of the question, how the question is being discussed. And we'll see quite a few examples and see the different ways they use it as we go along. But just to highlight to you that there's such different terms for the same thing. So this is kind of a repeat at this point to highlight the idea money valuing different amount at different period. This idea is called time value of money because money is worth different amount at different periods of time, right? So I won't go through this again. Now, having understood what we've covered so far, there's this question here. Which will you prefer? Receiving 1,000 today or receiving 1,000 1 year from today? Which one will you prefer? Without even doing any calculation. Today, yes, that's right. I'm glad you can straight away find because today worth more, right? So you can take the money today, then you invest it later. No, not later, but you can use the $1,000 today to invest it so that it grows more than $100, $1,000. I mean, 1 year later. So you're right. Today is worth better. Okay, so you don't even have to calculate. So there's some implications. Amount of cash flow in different period of time do not have the same worth, right? Be worth different amount, right? We need to take into account the interest rate in this. Some implications of time value of money. So we will cover this in lecture 3 and 4, capital budgeting. We will cover how to value stocks and bonds today. And there's some personal planning, which you can have a look. Okay, so we have a question here, which you can do in Excel. So suppose you have a 1-year-old son and you want to provide 75K in 17 years towards his education, college education. You currently have 5K to invest. What is the interest rate you must earn to have 75K? And that's at the end of 17 years, right? So again, I would like to, because this is the lesson part, I would like to show you the Excel. So please follow on with me to try to do this. Okay, so you're asked to find the interest rate, right? So interest rate, you use the rate function. Now, number of periods is given to us that is 17 years. Okay, 17 years. Payment, let's put at 0. We are not going to bother too much on that. Okay, now PV. What's PV now? Anyone would like to try? Negative. That's right. Why? Because you have to put in 5K, right? So money is coming out of your pocket. Negative 5,000. Perfect. Yeah, we're getting there. Okay, we are there. What is the future value? Yeah, positive. That's right. 0.5000. Very good. And this is the rate, 17.3%. I believe there's a working here as well. Yeah. Then the conventions have been mentioned here, negative and positive. Okay, so if you notice, there is this gas option, which I'll not be too worried about this, because in all cases except one case in our lecture in lecture 4, we will not use the gas function. So the gas function, what it does is that it sometimes when you calculate rates, there might be two rates. Two rates meaning there are two possible rates. And when this happens, you need to put the gas function, you need to ask the Excel to guess which rate you want it to be, which rate. So usually what happens is that there will be two rates. So it can be like 8% and maybe 42%, right? And so the gas function, if you don't put anything, will always choose something closer to 10%, which means you choose this. However, occasionally you want the larger rates here, right? So that's the purpose of the gas function. But don't worry too much about this. And we will see one case in lecture 4 that has this issue with the gas function. And the reason behind it is because when they plot the graph, so this is in later, I just want to just highlight when they plot a graph that is a quadratic curve, and so it cuts the axis into two parts, right? So that's why there is two answers, 42 and 8%, right? But we'll go through that in detail in lecture 4. Okay, I'll not go through this because we'll never use the table. All right, so you know what? Let's take a break for now before we go into multiple cash flow. Let's take a 7 minutes break. We're back at 8:12, shall we? And if you do have any questions during the break, do not hesitate to write them in the group chat. Okay, we'll take a quick break. All right, welcome back. Hope you have a short break, have some coffee or tea, or just go to the toilet. Um, so maybe at this point, I just want to do a small reminder regarding your GBA groups. So please reach out to your GBA group members. And for those who did not realize, but I've actually did a post on our tutorial group in the notification to confirm your groups. So if you do have any issues with your GBA groups, um, please reach out to me and we'll see how to shuffle or how we can help you in your groupings, right? So try to reach out to your groups as soon as possible to make sure that the students that are in the group are still in the course, because occasionally, sometimes the students might drop out along the way, right? Okay, so let's move on to multiple cash flow. So what's this idea first? Remember the PMT that I've been talking about is oh, just put a zero because we'll talk about it later. So that is the PMT that we're talking about. So this idea called multiple cash flows. So let's think about the idea first before we look at the formula. The formula looks scary, but don't worry because we have Excel, so we will not be using the formula. But let's think about it. What does it mean? It means this. We always dealing with one cash flow. Cash flow meaning one cash item, right? Present value, future value, right? One. In between, there is nothing that's happening. In this portion, what we are going to try to think about is what if every year there is some money coming in or going out, right? So it's a yearly affair, or it can be okay, it can be yearly, it can be monthly, it can be semi-annually. So same concept. It can be based on the compounding period. However, when the money comes in or goes out, it has to be compounded based on the rate that is given in the question as well, right? That is where this idea of multiple cash flow, and that's where the idea of this formula comes about. So when there is a cash flow, so I'll put this small little diagram here. When there's a cash flow, if you want to find the present value, you have to keep on discounting the cash flow back to year zero, right? To find what's the present value of the full so-called investment if there is cash coming in the years, every year, so-called, or every period. Let's not say year because it can be semi-annual as well, right? So you have to like discount it every time there is a cash flow coming in. You have to discount it, right? And how much do you discount it is based on the number of periods. So this is discount by one, this is discount by two times, and etc. So we'll have an example here. Don't worry, this will make it a bit clearer. So you have a auto dealer your auto dealer gives you a choice to pay 15,500 cash now, or make three payments of 8K, 8K now, 4K in the following 2 years. If the cost of money, so you see a different term, right? Cost of money is 8%, which do you prefer? Now, the answers is there, but let's tackle this on Excel. Hope you can follow me in Excel as well. So you practice for your TMA or future assessments, so on using the Excel. So you have the questions in front of you. Let's think about the two ways you can do it, right? So option one is just cash now. Okay, so you don't have to calculate that, nothing. Now, option two is 8K, 4K, 4K. Okay, let's put the period first. I'll just put year 0, 1, 2, because remember, we always start with 0. Now, let's say what's the cash flow, CF, right? The question say you have to pay 8K, 4K, 4K, right? So what is the present value? So you can calculate present value. So let's say PV, use the PV formula. What is the rate? The rate is 0.08 because you have put in decimal. Number of periods. So for year 0, the number of period is 0, right? There is no period here. Because we're calculating PV, payment you put at 0. What is the, see, FV? Actually, you know what? Okay, yeah, let's just do it this way. So what's the FV is negative, right? Because it's a payment, negative of this. Okay, you should get this answer here. So I hope everyone realized that actually for the first this one, there is no need to calculate PV. So this is PV of CF. There's no need because PV of 8,000 is just enough, right? There's nothing to calculate. But why I'll do this? Because I can do the dragging method. So I drag it like this, right? To just copy the formula because I have already put my references, my cell references, right? So I can just drag it like this to give me my PVs. So what is the sum of PV? So I'm just putting some formula text in case some of y'all miss the, so these are the workings that I've done. Okay. So this is the PV of your payment, right? 15. And this makes sense, right? It's a positive payment. So option 2 is lesser, right? What 15, 133. Now, maybe at this point, right, I want to highlight something as well, that if you are doing your TMA, okay, and you are going to copy things like, okay, I've done this in Excel, I want to copy and paste, like something like that, right? Copy and paste the answer as a picture in your working. You can do that. However, I want to highlight to you these things. Can you see that you are doing cell referencing here? So instead of just copying this like that copy, what you must do is you must copy, you do a screenshot. So it's a bit more troublesome, I would say, but no choice because when we mark, we need to have the references. So you do a screenshot to make sure that, let me just share, right? To make sure that the columns and row numbers are present, that you can see it. So in the lecture slides, you notice that you can't see it. That's actually very bad. That's a wrong way to do it. Because if your answer is incorrect and the marker is not able to trace where you get your references, you will not get the marks, or you can't get partial marks. So please include your column and your row numbers. Any questions for this calculation? Because now we're doing multiple cash flows now. Okay.
So how do you show the formula again? Like how does the formula pop up?
Okay. So use this thing called formula text.
Okay,
Equals
so
formula text.
when we do our assignments, do we need to do that, or we don't? We as long as the values are there.
So in your assignment, you have to do this formula text. Yes, you have to do it. Because if you just put 15,133, and let's say the answer is wrong, the marker cannot give you partial marks. But if you put your formula like this, then the markers are, oh, okay, maybe you calculate something wrong here, or something like that, right? So yes, you have to show the formula text.
Okay.
And also you have to make sure that you include your column and your row number. Because see, you're referencing K8, right? So let's say you just show this. Let's say this highlighted part is just showing your working. You will not get the marker will not know where is K8 because they can't see your Excel sheet. So you make sure that when you copy, you do a screenshot. Oops, sorry. You do a screenshot including the rows and column numbers and alphabets. I zoom a little more. So everyone understand this? That to include the row and row numbers and column alphabets. So make sure that this is, yeah, okay. That's good. All right, so I want, at this point, I also want to highlight another way to do this calculation. And this way, instead of doing manually like this, PV, 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 we use this thing called NPV. So it's a formula, NPV in Excel. Okay, so please follow me. Type NPV. It's called net present value. All right. So what's this formula trying to do? So it asks you what's the rate here. So 0.08, that's the same thing. Now, it's asking you to pull a value or multiple values, right, in a table. So what do you do here? You do this. Notice something. Okay, so I'm doing this like that. Notice something. I did not include year 0. So when you use this MPV formula, you cannot put year 0 inside. They only start calculating from year 1 because this formula assumes the first cash flow, here, the first cash flow to be in year 1, right? Now, what must I do? You plus year 0. Okay, so in case you want to use this formula, it's faster because you don't have to calculate manually, but you need to make sure, and I want to repeat this and emphasize this, the MPV formula, your cash flow inside here must be starting from year 1, and you add the year 0 cash flow outside the formula. You get exactly the same answer. It's faster. However, please take note of the things that I told you about. If not, you will get the wrong answer, right? Which is actually what is showing your slide as well. There is an alternative method. Okay, no questions on this? Okay, so I'm just going to stop sharing. We're going to jump back to the slides. Okay, so now to show you, this is actually, if you put this inside your assignment, in case your answer, okay, if your answer is perfect, is correct, you get full marks, right? But if let's say somewhere along the way you went wrong, because you did not put the row and column number alphabet respectively, the marker cannot give you partial marks because they are unable to verify where do you get this R5, R6, right? So this is a very bad example here. Yeah. Okay, so we have another example. A broker calls you and tell you that he has a great investment opportunity. If you invest 100 today, you'll receive 41 year in 75 in year 2. You require 50% return on your investment. So can you see that this is a different way of saying return investment, but it's also the interest of this risk. Should you take this investment? Now, this is the method using formulas. However, I always like to focus on Excel, so it is a lot easier. Now, I'm just going to jump back into Excel because so those that are very fluent in Excel, you can do this very fast. Okay, so we know year 0, year 1, year 2. So this is year cash flow. So in year 0, there is nothing, right? You receive $40 in year 1. So I'm going to put 40 here, 75 in year 2. Okay, so I'm going to use the NPV formula now to show you. NPV. What is the rate? 0.15 and this 2. See, it's very fast. So highly encourage you to use Excel. Don't bother using the formulas, and you should get this answer here. And the question is, should you take this investment? So anyone, should we take this investment? Yes or no? No, that's right. Because you're investing 100, but you're only getting 90. Wow.
So just to clarify the previous example, right? Under the cash flow, do we need to put negative 8,000 because we are spending money? I mean, or negative 4,000 and negative 4,000?
Okay, let's see. That's a good question. So because you are spending, yes, you can actually do that. You can put negative. Let me just see if the MPV formula would throw out some issues. I don't think it will, but let's just have a look. Yes. So okay, let me just go back to the question so that everyone can have a look at this. Okay, so you are right. In this question, we should be putting negative on our cash flows because you see, you are making payments, right? Payment of 8, 4, and 4. So yes, it should be negative here. And then because it's money coming out of the pocket, and your eventual MPV, because it's what you have to pay at the end of the second year, will be negative 15. That's right. So in this case, because you're receiving, so you don't have to, yeah, it's positive to you. Money is going into your pocket. Thanks for pointing that out. I think this is better. Yeah, let me revise this slide. I'll put the negative inside here. Maybe clearer for everybody. Okay, so now let's move on to this thing called perpetuity. So just now we talked about multiple cash flows, right? However, these cash flows are maybe for 2, 3 years and then it kind of stop. Now, what is a perpetuity? A perpetuity means that this cash flow goes on forever. So it just keeps on going on, never stops. So this is called perpetuity. It keeps on having cash flow for the entire life. And there's this thing where you have they calculated this formula. All right, you don't have to prove this formula, but you just need to know that this formula, you need to use this formula, is the present value of a perpetuity is given by C divided by R. And what is C? C is the cash flow divided by R, which is the rate or interest rate. Now, in this formula is important. So I'm going to put a star here. So whenever I highlight this formula, it means that there is no Excel method to calculate this, right? There is no perpetuity Excel function. So you need to use formula to this pen and paper and calculator to calculate this, right? So please remember this formula. You need to know this formula. Yeah. Okay. Now C. So this C is very important. This C is the cash flow that starts 1 year or one period from now. So not 1 year, because there can be two. So one period from now. So what does this mean? It means that let me draw the timeline here. This year 0, 1, 2. Okay, it's not year, period 1 period, because yeah, it can be semi-annual. So the cash flow C must start from here. C, C, C. So C is 1 period from now, right? So it makes sense, right? So C is 1 period from now. So this C must be one period from now. And then the question is, what if it isn't? Okay, we have a question for that. We'll look at it in a bit. So we need to do shifting of the cash flow. So now it's getting a bit more complex really, right? So let's have a look. Let's look at a simple example first. What is the value of a British consul or a perpetual bond in Britain that promise a £15 each year forever if the interest rate is 10%? So we just use the formula, quite easy. We know that we check first. Okay, we check. Is this £15 1 period from now? Yes, it's 1 period from now. Okay, so we can just take 15 divide by 0.1 and we get this 150. Okay, so you just use formula. Again, I'll highlight there is no Excel function for perpetuity, so we need to use the formula. Okay, so this is the question that I want to stress to you why this one period from now is important to consider. Okay, let's look at this question first. Okay, in order to create an endowment which pays 100K per year forever, how much money must we set aside today if the interest rate is 10%? Okay, so how much must we set aside today? Okay. Now, this endowment is going to pay forever, so it is a perpetuity. So, if the first payment start 1 year from today, okay, so if you start 1 year from today, it meets the requirement, right? C must be 1 year from today, right? Or one period from today. So how do we use the formula? We just take by 0.1. This would give you, okay, so I'm just using the perpetuity formula directly. Now, the question is, the second part of the question, which is the tricky part, is first payment starts 3 years from today. Okay, so you know what? I'm just going to hop over to my notes here. All right, let's just go here. So you have the question in front of you, right? So, okay, let's type this. So, right. Okay, so let's pull out our pen. So let's draw the timeline here. 0, 1, 2, 3, 4, 5. So the question is, it starts, is it 3 years? Let me just check again. First payment starts 3 years from today. Okay, so where does the first payment start? So 1, 2, 3. So payments start here, right? Everyone agrees? It starts on year 3, right? Because it starts 3 years from today. Now, what's happening here? Okay, so let's pull out a different color. Okay, so what am I going to do? I'm going to use the perpetuity formula, but perpetuity formula says that the cash flow must be one period from today, right? So if I'm using the perpetuity formula, what's happening? The reference period is here at year 2, and it's 1 year from today, right? So I'm referencing at year 2 here. Now, so I will take C, which is 10K, divide by 0.1. And this gives you the perpetuity, the PV of the perpetuity as of year 2. Okay, does everyone understand this point? This is a very important concept. I'll pause here for a short while. Everyone understands? Oh, sorry, you're right. It's 100K. Thank you, thank you. Yeah, thank you. Okay, so perfect. So no questions. So your reference period is year 2 now. Okay, so you calculate this as 1 million, 1M. I'll just put 1M here. Now, this is reference to year 2. That's why I have the dotted line year 2. However, are you in year 2? No, you are in year 0, right? So what must you do? From year 2, you have to, I'm just going to use a different color now. You have to hop, I like to say hop back like a bunny, like 1, 2. So you need to PV back by 2 more years. So you hop it back by 2 years. So what must you do? You take 1 million, you must shift it back by 2 years. So it's 1.1, which is squared, right? So 1 plus 10% squared. And this will give you the answer 800 plus, I think 800K plus, something like that. 800 and blah, 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 something. But the concept is that the value of your perpetuity now is only 800 plus K compared to 1 million, because when you use the perpetuity, you have to shift it back by 2 years simply because your reference period when you calculated your perpetuity is in year 2, and therefore you need to shift it. Any questions? Because this is an important concept to understand where your reference period is when you're using the perpetuity formula.
So could you explain how you get the 1 million divided by the 2 years, the 1.1? What formula would that be? Sorry.
Sure, no problem. So let me just erase this. So what's happening here? You are in year 2, right? You have calculated your perpetuity as of year 2. So actually when I say shifting it back here like this, I'm using the PV formula, rather present value. So present value, PV, equals to your future value, which is 1 million, divided by 1 plus 10% square, right? Because you're shifting by 2 years.
Okay, noted.
800 plus something. Yeah, most welcome. So the important part is that you need to shift your cash flow back by 2 years because your perpetuity reference is at year 2 here. Any other questions? Okay. All right, sure. We can have a look at that as well. Okay. So let's say start at year 4, okay? Start at year 4. So that means the perpetuity start paying at year 4, meaning that you have cash flow. You start getting cash flow at year 4, right? Everyone agree? If you start at year 4, means that I start getting money at year 4. Okay. So what happens? If I'm using the perpetuity formula, C divided by R, remember the formula says C must start 1 period from today. So where's my reference period now? If I'm using the perpetuity formula, reference is here, right? So C divided by R, C divided by R is the perpetuity formula. The reference period is in year 3 now, right? Because the formula say, you use this formula, your C must be 1 period from today, which is the reference period at year 3. Okay, so this will give you same thing, 1 million, right? There's no change. Now, what will change? You will have to, after you get the 1 million, you have to shift it back to year 0, right? Year 0 is today. Your year 3 is just a reference period for your perpetuity formula. So you need to shift back 1, 2, 3. So you need to do a PV of 1 million, 1 plus 10%. Since you're shifting, you are bunny hopping back 3 years, you need to do it like that. Okay, so if you notice, you need to be very clear, like what is the formula actually trying to do, all right? So once you are clear with that, it is not so difficult when you shift the cash flow. So you know what? I'm just going to flip back to this slide here, see, to point out the importance of this, right? So first payment starts 1 period from now, right? So you need to define where is your now, and then it starts 1 period from it. Okay, we are good. No other questions. Okay, so we have talked about perpetuity, right? Now, what happens if your perpetuity grows every year? So now it's a growing perpetuity. So it grows every year, meaning what? You receive $10 this year. Next year, you receive $12. Next year, you receive $15. Another year, you keep on growing upwards. So this is called growing perpetuity. Again, for growing perpetuity, you need to memorize this formula. There is no Excel function. So I put a star here. There is no Excel function for this. And it looks quite simple. The only difference is that you need to minus G, and G is the growth rate or growth factor given the question. And usually G is less than R, right? It must be less than R in order to use formula. If not, this formula doesn't work. It's an assumption that has to be there. So we do have a question on growing perpetuity here. So let's have a look at this. The expected dividend next year is 1.3. The dividends are expected to grow at 5% forever. The discount rate is 10%. What is the value of this promised dividend stream? Okay, I want to highlight something straight away. Can you see this thing called expected dividend? Anyone knows what does expected dividend means? And it's next year. So, okay, estimated, yes, there is some estimation. So what it means is that it is expected. So it's not now, it's not the dividends now, it's estimated next year, right? So it means that this is in year 1. Okay, it's not year 0. And of course, they say next year as well. It kind of like confirm as next year. Sometimes the question will be a bit vague. They don't say next year. So you need to know expected is always what you expect is next year, right? Or next period. So they have done this like that, 1.3. And you know that it will grow forever at 5%. So this is a growing perpetuity formula. So you keep on growing like this. And so you simply use the growing perpetuity formula like that. The formula is easy. So I think what's important as well in this kind of time value of money question is when you see these examples as we go through the lesson, they are already categorized for you. Okay, this is growing perpetuity. This is multiple cash stream flow, cash streams. This is a PV question. So sometimes the tough part, right, when you do your assignment is that you do not know what is it, right? So I hope that you can try to figure out like the reading, okay, for when they say forever, okay, sure, when you think about perpetuity. When you see growth, okay, so you're growing perpetuity. So hopefully you can pick up that depending on the way the question is phrased, what kind of words they use, you need to first categorize the question in a certain type of question. Then you're able to use the formulas accordingly. Okay. So for this growing perpetuity, we are going to value stocks now. So remember, earlier I mentioned one of the things we are going to do is stock valuation. So for stock valuation, we have this thing called...
Sir, sorry, Raja here again. Sorry to interrupt. Both the growing perpetuity and perpetuity, right? I'm just wondering, this particular value, I'm not understanding what is the meaning actually behind this value. This is the value we need to have now, or what does it exactly mean?
This value here, is it?
Yes, that's right.
Okay, so this is we are calculating the PV, right? Present value. So what does a present value mean? It means that what is the worth of this financial product? What is the value, almost like the present value, meaning how much you pay for this investment product now? Because remember, this product is going to give you 1.3 every year forever, right? So the question is, okay, if you're going to give me 1.3 forever, how much should I pay for it, right? If I want to buy this product. This is where you do this calculation to say, oh, okay, the present value is $26, meaning that I should pay $26 to buy this product. If somebody is going to charge me $30, maybe it's not so worth it because based on my calculation, it's not so worth it. So it's basically to calculate, what is the worth of the product?
Okay, so it's nothing to do with how much dividends you are getting or what the dividends. So I guess it's kind of equivalent of all the dividends added up in the future and it's calculated in your present value.
Yes, that's right.
Okay.
That's right. You're right. So,
okay.
And because it is forever, so that's why when it's forever, it gets a bit difficult to, I'll agree with you, a bit difficult to understand. Forever, that means I only pay $26 to get forever. Yeah, so, but then there is a mathematical way where the value actually converges. That's why you only take C divided by R, or in this
Okay.
case, growing D divided by R minus G. Yeah.
Right. Okay. Noted. Thank you.
Welcome. So yeah, is the worth, like how much were you willing to pay, right? When you calculate present value in this case. And in this same form, we can use the growing perpetuity to value stocks, stock valuation. So the stock valuation usually is called DDM, dividend growth model, dividend discount model, sorry, constant growth dividend discount model, DDM, or Gordon growth model, GGM. So there's a few names, same thing, DDM, GGM, and yeah, so there's quite a few numbers. And the idea of this dividend growth model is based on the growing perpetuity formula. And what's happening here? So what's happening here? Let's look at it. Let's say you buy a stock. Okay, we know that the stock is going to give us dividend, right? As long as we hold the stock. So if we hold the stock forever, the stock is going to give us dividend forever, right? So this sounds like a perpetuity already. And we know that the dividend generally goes upwards. Generally, I mean, sometimes the recession, no dividend, but generally it goes upwards, which is why we can use this thing called a growing perpetuity, because the dividends that we receive is like the cash flow coming in, right? Like one earlier is 1.3, 1.3, I'm getting 1.3, and it's forever. So that is why we can use the growing perpetuity as a way to calculate the value of the stock. Now, what do we use here? So P naught, which is the value of the stock now, the firm value or value of the stock, equals to dividends in year 0 times 1 plus G. So what's this doing? Here you are getting the, remember earlier I pointed out expected. I asked you what is expected. What does expected mean? Expected means the year ahead. And remember, for growing perpetuity and perpetuity formula, C must be 1 period from now, right? C must be 1 period from now. So that is why you need to calculate what is D1 or dividend at year 1, because it's 1 period from now. And then you use the R minus G here. So D naught is dividend now, D1 is 1 period from now. We have an example, so do not worry. We try to understand what's this. Okay, so suppose Big D Incorporated just paid dividends of 0.5, 50 cents. So what, can you tell me, is this D1 or is it D0? Is it dividend at year 1 or dividend at year 0? Correct, D0, right? Dividend at year 0. Okay, because it's just paid. And it's expected to increase dividend by 2% per year. If the market requires a 15% return on asset of this risk, how much should the stock be selling for? So using the DDN, we can find 0.5 times 1 plus 2%, right? Growth rate. Then we take 15% R minus 2%, right? So this should give us the answer. So this is the value of Big D's stock. So what's the price of the value of the stock? So this is the price. So the stock should be selling for, you should get this, $3.92. Okay. So to bring in context again, this way of calculating the value of the stock helps you as an investor determine whether the stock, is overpriced, overvalued, or undervalued, right? So that you can determine, okay, should I buy this stock now? Based on my calculation, maybe it's $3.92, but in the stock market, if I check the stock market, is $4. Okay, so maybe I don't want to buy because in the stock market is too high, right? So this helps you determine whether you should buy a stock or not. So it values the stock for you. Okay, so now we'll move on to next. Okay, so that's all for dividend and perpetuity. Perpetuity, growing perpetuity, and valuing of stocks. So I know if in case you want more questions, remember there is the self-review questions after the end of this lecture notes and as well as some lecture 2B. Also, I want to highlight as well that I re-uploaded all the slides with the answers for the self-review questions because I realized that the self-review questions no answers, so it can be a bit tough to, if you want to review yourself and you don't know what's answer, doesn't make sense, right? So I provided answers for you for the self-review questions at the end of all the lecture slides. So in case you're using the old slides, there are no answers, but the new slides that I've uploaded all includes answers for self-review questions at the end of each lecture. Okay, so moving on to ordinary annuity now. So what's ordinary annuity? So the idea of annuity is that we have cash flows, okay, coming in like a perpetuity. However, a perpetuity would stop, right? I'm sorry, wouldn't stop. A perpetuity wouldn't stop. The cash flow keep on coming in forever. Now, an annuity, the cash flow stops after a certain year. Okay? So because the cash flow stops, the formula is slightly different. We can do it this way, like this, cash flow coming in at each and you discount it. So we're calculating the present value of our annuity, right? There is a formula given by this. I want to highlight that you can use Excel for ordinary annuity. However, you do need to know the formula because there is a different type of annuity later that we'll talk about that can only be used using a formula. So I want to take some time to explain this formula here. Okay, so the annuity formula or ordinary annuity formula is given by C, which is the cash flow, the sum of the cash flow is it $100 per year, this amount divided by R. So very similar, C divided by R looks like a perpetuity, right? However, you need to multiply by a discount factor because this is the discount factor where it is 1 minus 1 divided by 1 plus R times T, right? So unfortunately, it's easier to just memorize this formula. You don't have to know the proof. There's a way to show how this formula comes about, but don't worry about it. Memorize this formula or write it down in your notebook whenever you do a question like this for ordinary annuity. Okay, so in other words, what's happening here? Ordinary annuity. It means what? It means this. Yes, you are given formula sheet, and I believe it's an open book exam as well, unless the last few years were open book. So unless certain things change, this year should be open book also. So yeah, you can refer to it. But sometimes easier to write it on the side because when you refer to your lecture slides, right, you might not be able to find which portion of your slides it is. So it might be easy to write it on a piece of paper. Formulas that you need to refer to. Okay, so ordinary annuity, remember I mentioned that the cash flow is coming in. However, it's coming in only for like 3 years or 2 years or 1 year. Okay, 1 year is not bad. Maybe 4 years. So in this case, the cash flow comes in for 3 years, right? And what you do is you just discount it. You just discount it and you get this, right? This is a ordinary annuity formula. Again, because you notice something, this C divided by R is almost like a perpetuity. So the same condition applies. First cash flow starts 1 year from today. So this is another important thing to take note of because it's just referencing almost the perpetuity formula using the same idea of perpetuity formula. So we have an example here. Let's have a look at this. And the focus is I want to use the annuity formula. So okay, let's read a question first, right? So you can afford 1500 monthly car payments. Okay, what is the maximum car loan you can take if the interest rate is 5% for 7 years or 84 months, right? Because, okay, so at this point in time, I want to highlight something. Whenever you have things like months, years, interest rate, right? And this interest rate is your nominal interest rate, which is in a year. The rule, okay, this is very important. This is very important now. The rule is that you need to reduce your values into the lowest denominator. Okay, I repeat again, the rule is that you must reduce your value into the lowest denominator. What does this mean? It means that if you have months, you have years, these are years, right? You have to change everything into months. So this is in months, okay? This is in 7 years, they tell you it's 84 months. Okay, use 84 months. Now, your 5%, you need to take 5%, divide by 12. So everything need to convert to the lowest denominator. Lowest denominator in the sense of this is months. You cannot convert everything to years. Okay, you can, but it becomes very complicated. So what am I saying? You cannot say, oh, I want to times this by 12. I want to take 7 years and times the payment by 12. Everyone understand this. This is a very important concept because there are previous years, there are some questions like this question and people just times 12 and you get it wrong. Anyone needs me to repeat? And maybe a question for all of you all. Do you know why we cannot times 12, shift everything up to a bigger denominator? Why guys say that you always must use the lowest denominator? Yeah, okay. Let me repeat again. So in this question, this question is a good example, I would say. Compounding, you're right. Perfect, David. I think you understand this. Okay, so let me repeat this again. Now, you have this question here, monthly car payments, right, for 7 years at 5%. Now, the thing is, you must use it, you must convert everything to monthly. What does this mean? It means that you need to take this 1,500, you need to convert 7 years into months and take 5% divided by 12. So you convert this into a periodic rate. Right? Now, the thing that you cannot do is some people might say, you know what, since I got years, so this in years, this is in nominal, which is in years as well. What if I take 1,500 times 12? So I convert this into years, then I just take whatever value, the 7 years and this, right? I use these 3 values in rate. The thing is you cannot do that. You get the wrong answer. You get a totally different answer. The reason being is because of what your friend has mentioned, is because of compounding. So I don't want to prove to you, as in, I don't think we have time to do the proof and everything. However, because of compounding, what must you do? I'll just try to explain to you in words, right? So you just think about it. But if you want, you can eventually do the proof yourself on the side. But the idea behind it is that if you times this by 12, recall that payment at different part of the month is worth different amount of money, right? Where the initial concept that we talk about before even we discuss this lecture, right? I would say different money in different period of time worth different amount. So if you times 12, are you considering how this 1,500 is worth different amount in different months? No, right? You're not considering that. You need to so the thing is you need to consider that 1,500 in January is worth different in February, is worth different in February, March, etc. So you need to do the compounding and form a value here, some value. Then you can take everything in years. So the easier way and the right way to do it, do not do this. I'm going to erase this. This is wrong. You convert everything into the lowest denominator, which is months, right? So 84 months, 1,500, and you take 5% divided by 12, as given here. Once you have that, this is an ordinary annuity. I'm going to use the ordinary annuity formula given by C divided by R, and R is 5% divided by 12. R is given by this, and N is given by 84, since there are 84 periods now. So this is the value here. So ordinary annuity, I encourage you to use the formula, the ordinary annuity formula as given by this thing here. However, because you have Excel, what you can do is no, there's no wait. There is, okay. Let me show you. There is. However, I encourage you to use it on the ordinary annuity formula, because the next slide, we're going to talk about growing ordinary annuity. And when there's a growth factor, there is no Excel formula. So, okay, ordinary annuity there is. Thanks for reminding me. Let's have a look here. How do we calculate the... So, we use the PV formula, okay? Now, let's plug in the values. What's the rate? So rate is 0.05 divided by 12, right? Remember, because we are taking a money. Number of periods is 84. Okay. Payment. This is where the payment come in. Because ordinary annuity has cash flows coming in, right? So this is where the payment function works. So the payment now is now, this is a minus, right? Because you have money coming out of your pocket. Everyone, yeah, money coming out minus because you need to pay money. What is the FV at the end? 0, because you keep on paying until that's all. There you go. Can you see? This is the same answer as very close. I think there is a bit of rounding error here, but don't worry about it. So there's a bit of rounding error, but this is close enough. Okay. So I'm just going to use formula text to show the formula here. This is what we do. So again, I repeat, negative because money is coming out of your pocket. You are paying the car payments, and this is what you have. Is the maximum car loan that, and the car loan you're getting the money, right, from the bank, getting a loan, so it's positive to you. Okay, we have another ordinary annuity question. So you purchase a car, you schedule to make 3 annual payments, 4K per year. The first payment starts 1 year from today. Fine, very good. Given the interest rate 10%, what's the price you're paying for the car? Now, in this case, I'm not going to jump over to the Excel. I have actually put the Excel formulation here. So you have 10% interest, so 0.1, right? You use the PV formula as well. 3 annual payments, so NPER is 3, given here. Now, you're making annual payments of 4,000, so it's negative, right? You're going to pay up 4,000, so negative 4,000. I put 0, your FV is 0, and so this is the price of your car. Now, second question, future value of annual payment. You plan to save 3,000 every year for 4 years. Given the 8% interest, how much would your bank account have after 4 years? All right, so I'm using the FV formula now. You know there's 8% interest. How many periods? NPER is 4. you plan to save 3,000. So your money is coming out of your pocket, right? You're saving 3,000, negative 3,000. And what is the PV? Present value is 0 here. And you calculate FV as this. So the ordinary annuity, there is an Excel formula. You can use it. It's basically the same PV formula, but you use the PMT as the cash flows. Okay. Let's take a break here. Let's come back at 9:15 before we finish off the last part of today's lecture. And then we'll answer the questions as well. So feel free to put questions in. right? Welcome back to the last part of today's lecture. I do see a question here. What are the word hints to know if it's a FV or PV? So you really have to look at the question, right? So in this sense, the last question we talk about, how much will there be in your account after 4 years? So after 4 years it count FV. So you really have to read the question. There's not really hints. Most of the time, it's a bit more vague. However, you read the question, if they say after 4 years, it's FV, right? If they say what is the value of the account now it's a PV. Okay, so now let's move on to bond pricing. The idea of it is that, first of all, okay, let me try to explain what's a bond first, in case some people do not already know. So a bond, basically in simple terms, is a piece of paper. Okay, it's a piece of paper that says that I'm going to lend you this amount of money. I, meaning as an individual, I'm going to lend this company a piece of money, a sum of money, and then the company is going to pay me back the money, and then the company is going to give me a paper, this piece of paper. Okay, at the end of 3 years, maybe let's say I'm going to lend money for 3 years. At the end of 3 years, I'm going to bring this paper back to the company, and the company is going to return the money that I own or I loan to the company. So for example, I pass the company 10,000. The company is giving me this piece of paper, and this piece of paper is called a bond, right? At the end of the 3 years, I'm bringing this bond or this piece of paper back to the company, and the company is going to return me my principal. Now, this is a very simple term of a bond, okay? And this is, of course, a very plain, normal bond, right? Because now bonds are very complicated. There are a lot of functions. The question here is, or the interesting thing about a bond is that, okay, I'm going to get back the same amount of money when I return the piece of paper, which is a book called bond. The question is, where is the interest, right? Of course, if I lend the money to the company, I'm expected to get some interest, right? So the interest in a bond is quite interesting. It comes in the form of this thing called coupon payment. And I'm talking about normal bond, right? Because now there's a lot of fancy bond and there's a lot of funny things, right? Let's talk about normal bond now. So in a normal bond, the interest comes in coupon payments, which are annual payments given to you. Okay, and that's the interest amount. Because at the end of the day, when you return a piece of paper, you're just getting back your principal amount, right? So the principal amount is called a face value. Maturity is how long the bond will expire, is in 3 years, for example. And this coupon payment here is based on a thing called coupon rate. Okay, so a coupon rate is different from the interest rate of a bond. Let's have a look at it. Let's look at what it means. See? So the coupon payment is based on coupon rate, and the coupon rate is determined in the bond. So simple terms, a bond is just a piece of paper that says that you have lent some money to the company. So because the coupon payment based on the coupon rate is given to you on a can be annual, semi-annual basis, it's like an annuity that keep on coming in, right? And we know that why is it not a perpetuity? Because we know that the bond will mature in, let's say, 3 years. So we know that the money coming in is only for 3 years and finish. That's all. So it is somewhat like an ordinary annuity. And that's why we can use the ordinary annuity formula to determine the bond price or the present value of the bond. So how much were you willing to pay for the bond? So in this sense, remember why I mentioned that you kind of need to know ordinary annuity formula just a bit, like even though you have Excel, because this is very similar to what we see here. Can you see? Instead of C, we have the coupon payments, and R is your interest rate, or we call it in a bond way, we call it yield to maturity, YTM. Okay. And at the end of it, you need to add back your par. What's your par? Par is your principal value, principal. PRIN, your principal value, right? So you need to add back your principal value here. Because remember what happens? At the end, when it's mature, you return a piece of paper, the company gives you back the money that you loan. So you need to have this return on principal here. Of course, it's being now discounted as well because there's some discounting, right? As it's being returned after 3 years. So at this point, I want to highlight something. Can you see the R or the yield to maturity? It is not equals to the coupon. Is not equals to the coupon rate. The coupon rate is a separate rate. So there are two rates here if you look at bond questions. So coupon rate determines the coupon amount that's being paid and the yield to maturity, which is the interest on the bond. So what is the price? So this example, what is the price of a 5.5 annual coupon bond with a face value of 1,000 that matures in 3 years, assuming discount rate of 3.5%. So what's this? This is R. This is your coupon rate. So these are two different rates. So please take note. Everyone understand this? That there's two different rates? Any questions on this? So, okay, I guess there's no question. So the coupon rate determines your coupon payment. So how much coupon must you pay? 5.5% multiplied by the face value equals to $55, right? $55 per year. Okay. And then you can plug into your PV formula. So I'm not going to hop into Excel, but we know your PV is, first thing is your rate, which is 0.035. We know that NPR is 3 years. 3 years. We know that the cash flows coming in is 55, as we calculated here using the coupons. Now, your future value, recall that at the end of the bond, you return the paper, the company gives you back the principal, right? So future value is 1,000. This is the important part that you need to take note, that you have a future value here. Any questions for this?
So in summary, the payment under the PV is where you put the 55 because we were always putting the payment as 0 so far, right?
Yes,
So,
correct. So
I guess this is where the payment comes in and you put a separate coupon payment rate into this particular field.
Yes, yes, that's right. That's right. For ordinary annuity, because yeah, that's where the cash are coming in. Yeah, payment. That's right. Okay. Okay, so that's all for bonds. There are more questions on bonds for in the recorded lecture, but let's move on to annuity due. So annuity due, right, is where this thing, because we have always been talking about, okay, the payment is 1 period from today, right? So it's 1 period from today. Now, what if the payment comes today, immediately now? All the payments comes immediately. This is called an annuity due situation. The payment comes at the beginning of the period, right? Now, this is very simple because we have Excel. We just simply, when you see your Excel formula for PV, for FV, is the same thing. You just go to the type. The last component type is usually in a bracket, meaning that by default is beginning is at the end of the period. So it's a normal case. And in all questions, is always normal case unless otherwise stated. If it's stated that it's an annuity due situation, it means that it is, you put a 1. So you put a 1, as you can see here, put a 1. 1 means the cash flow starts at the beginning of the period, right? In a formula sense, you just add, or not add, but you multiply by 1 times R. Okay. Okay. For annuity, want to cover one last part. Annuity is this thing called growing annuity. So growing annuity means that the annuity keep on growing, similar to a growing perpetuity, keep on growing by the function G. Unfortunately, for growing annuity, there is no Excel formula, so you need to know this formula here. So if you refer to your growing perpetuity, it's very similar. You just need to minus G, right? You minus G here, and then you add a G here. So this is the formula for a growing annuity, and there is no Excel formula. So this is important. I put a star here because you need to memorize this or write your formula sheet. So example of a growing annuity, let's look at this. A retirement plan offers 20K per year for 40 years, increase increase the annual payment by 3% each year. What is the present value of the retirement if the discount rate is 10%? So can you see that your investment keep on increasing by 3% as you mentioned, as seen here? Now, because there is no Excel formula, you have to just plug in the values for a growing annuity. So the important thing, take note, is that because it's 3%, you need to add a 3% here. You put in for 40 years, 40 years is here, and you find the answer. I think there is a bug on my on this program on my iPad. I will see whether I can fix this issue in the next lesson. Okay.
Sorry, can I quickly just run through? Annuity means we have to make a payment or we get a cash flow coming in. And what's the difference between due and ordinary again? I think I failed to understand that.
Okay, so maybe I go to your second question first. The difference between due and ordinary. So ordinary, the payment starts at the end of each period here. Now, due is where it starts at the beginning of the period. So you shift all the payment, you shift it all back by one period. And that is why that's why you must multiply by 1 plus R.
So this is something we have to do a payment. I'm just trying to understand what annuity is actually.
Okay, so the idea of what's an annuity is that, okay, so you understand what's a perpetuity, right? Perpetuity means they have cash flow coming in non-stop, right? Forever. Annuity is the same as a perpetuity. However, the only difference is that for annuity, there is a stop date. So it's only coming in for 5 years, the cash flow coming in for 5 years, and that's all, finish. Or 3 years and finish. So that's the meaning of annuity. Ordinary
Okay, so
annuity.
that means it's not really cash flow out, it's more like you are getting the cash flow, just like your perpetuity.
Okay, it can be cash flow out or cash flow in. Both will work the same. Just remember, cash flow out or cash flow in, you just have a negative or positive.
Negative
right?
or positive. Okay, right. Okay.
What's your second question again?
No, those were the questions actually. And so just to clarify, so if it's due, then we use the one under the type. So if it's ordinary, then we still leave it as 0 as per for the Excel formula.
Yeah.
Under the
For ordinary, you don't even have to write the 0, is by default. But if you want, you can write the 0 as well.
right. Okay.
Yeah. So in all questions in your assignments and even exam, is all default as ordinary annuity unless otherwise stated. Okay. Now let's go on to loans. So we have types of loans. We have a pure discount, interest loan, and amortizing loan. There are 3 types of loan that we're going to talk about. So pure discount loans means that you receive the money from the bank. Okay, I'm just going to explain to you like in layman terms or simple terms. You receive the money from the bank. At the end, you just pay the money back after 3 years, 2 years, however long you loan the money. That's all, finish, right? And when you pay the money back, of course, you pay more because there's interest, right? So these are simple terms. So you can read the details here and explain. So for this pure discount loan, So this is a pure discount loan example. In the interest of time, I will not go through this. It's just, you just divide by this. Now, an interest-only loan. So just now we have pure discount loan. Now, what's an interest-only loan? So the second type of loan, it means that you pay interest each period to repay the principal at some point. So what does this mean? It means that you borrow money, okay? Every year, let's say you borrow for 5 years. You borrow money from the bank for 5 years. Every year you pay back the interest only. You just pay back, maybe the interest is 10%, you pay back 10% of, I don't know, 1,000, $100, pay back $100. At the end of the 5 years, you pay back the interest. Pay back the interest on the last year and the principal of the full principal. So you only pay back the interest on a yearly basis. Now, those two loans are more just for understanding. Actually, what we need to focus on for this module is this thing called amortizing loan, amortized loan. So what does amortized loan means? Amortized loan, which is what I want to spend a bit more time on, is where you are paying a sum of money every year. Okay. However, this sum of money will repay two components, the interest and the principal. Okay. And every year, the proportion of this sum of money that's paying the interest and the proportion of money that's paying the principal changes. Okay, I'll repeat again. Amortizing loan means that every year you pay a sum of money, but the sum of money will repay a portion of interest and a portion of the principal amount. And so at the end of the amortizing loan, there'll be zero, no more, finish, because you have repaid all your interest and all your principal. Classic example is your mortgage loan. So let's calculate this now. Let's go into the details. Okay, so suppose you have $1,000 kind of loan, 10% at 3 years, so 3 equal payments. Okay, this is happening again. Okay, now the first step to do is to calculate this, your payment. So I'm going to use the PMT function. So I put in 10%. You borrow for 3 years, and your present value, PV, you're getting 1,000 in your pocket, right? Positive coming into your pocket because you are getting this loan. However, at the end, your FV here is zero because you have paid off everything. Remember, I told you amortizing loan, you pay every year, you keep on paying both interest and principal, and at the end, you left zero because you don't have to pay anything. Okay, so you calculate what is the payment required per year. And this payment would be split into principal and interest. And how we split it, okay, let's figure out how we split principal and interest. Okay, I will skip this because these are the calculations for the explanation. I'll go to the next slide here. So the slide that I skip is how we do the calculations here. I'll explain to you the calculations here so it's easy to visualize as well. So at the start, remember, we take a loan for 1,000. Remember, our payments is calculated using our PMT formula, and it's 402. And the payments are every year is the same, just 402, 402, 402, and for 3 years. Now, how do we calculate the amount of interest we pay? So amount of interest we pay, we just take, remember the loan is 10%. So flip back to the slides if you forgot. It's 10% times the beginning balance. So beginning balance initially is 1K times 10% is 100. Okay, so you pay $100 of interest. Now, we know that we pay a total of 402 payment, right? And in this sense, $100 is interest. So what is the principal amount? We take 402 minus 100. So we get this. This is the principal amount that's being paid. At the end, what's the ending balance? The ending balance is the ending balance of the principal. So we take 1,000 minus 30 2. So we get this. Okay. Now, then what happens to next year? You bring down this ending balance, go to beginning balance. So this is the principal amount that's left. Okay. Your payment remains the same, 402. The interest, what's the interest? How do you calculate interest? Interest is 10% of beginning balance, right? So it's around 70. What's the principal amount that is a portion? What's the proportion of principal that is being paid? You take 402 minus 70 equals to 332. Now, what is the ending balance again of the principal? You take 698. So I'm going to use a different color here. 698 minus 332. And we get this, 366. All right. So what do you notice here? I want to highlight something. Do you notice that the interest amount decrease over time and the principal amount that you pay per year increase over time? And this is the amortizing loan. So at the end of the third year, can you see the balance is 0? Your loans disappear, finish. So every year you keep on paying interest, principal, interest, principal. However, the amount of interest that you pay decreases. The amount of principal you pay increases. Even though the payment you pay remains the same. For every year, you just pay 402, but the proportion of it, the split of it changes. Any questions for this? So I highly encourage you to at least try to reconstruct this amortizing table by yourself in Excel to able to see the flow of the money. And whatever that I explained here is is shown here, right? These are the proper kind of calculations. So this is a view of it. So interest, so like I mentioned, interest amount keep on decreasing, right? The interest payment keep on decreasing. And your principal amount keep on increasing. Okay. Last part, I know it's quite heavy, this lecture. Now, last part we're going to talk about is inflation. So inflation, okay, everyone roughly know what's inflation? Does anyone have never heard this term inflation before? Okay, so everyone has heard of it, I guess. That's good. So basically inflation, right? The idea is that inflation is the rate at which the prices of goods increase, right? And we know that inflation causes things to be more expensive. Okay, so we have money growing at nominal rate, right? Meaning what is the rate that the banks will pay us. However, this nominal interest does not mean that, okay, you have a saving account of 10%. Does that mean that every year you are 10% richer? No, right? You're not 10% richer because inflation is going to reduce the rate or the so-called your wealth, right? So maybe at the end you're only 7% richer because inflation is 3%. Okay, that's a very bad example. You cannot minus like that, but that's an approximation. So the real interest rate is measure the purchasing power of your actual investment after accounting for inflation. So now we have this thing called real interest rate. Now, the thing is, to convert between nominal and real rate, we need to use this thing called the Fisher equation. So the Fisher equation equals to 1 plus nominal equals to 1 plus R times 1 plus I, where I is the inflation rate. So remember just now I mentioned, if your saving give you 10% and inflation is 3%, your real rate is 7%. That is wrong. You cannot take nominal minus inflation of 3% give you 7%. That is wrong. You need to use Fisher equation. So that's why I immediately corrected myself, because that is a very typical or very common mistake. So when to calculate nominal rate or real rate, you need to use the Fisher equation. So real rate has been adjusted for inflation. Nominal means that have not been adjusted for inflation. So let's have an example here. If the interest rate on a 1-year government bond is 5%, inflation is 2.2, what is the real rate? So remember, you cannot take 5.0% minus 2.2%. Oh, real rate is 2.8%. No, this is wrong. This is wrong. You cannot do it. I'm just going to put a big X here to remind you not to do it. You need to use Fisher equation, where you take 1.5, 1 plus 5% equals to 1 plus real plus 1 plus 2.2. And this is the correct answer. Now, some of you all might read other textbook and then you Google and check. A lot of people are using this because this is a approximation. The real way to do it, or the correct way to do it, is using Fisher equation. This is the approximation method. However, because we are dealing with interest rates, a small difference, right? 2.8 versus 2.74, even though it's just a bit 0.06, right? The difference is 0.06%. But this small percent, because of the idea of compounding for many years, the difference can be a lot. So that's why we want to be very accurate. We use Fisher equation, not the estimation. So this is a good part where you say, if it's a nominal cash flow, use nominal. So actual cash flow, nominal cash flow, use nominal discount. If you are a constant dollar, use constant, use real cash flow. I think I will need to reinstall this app. I think there's a bug going on. Okay, so we have an example here that I'd like to go through. So you own a lease that costs you 8,000 immediately, increasing at 3% a year, which is a forecast inflation for 3 additional years, right? So you have 8,000 and you pay immediately, and for 3 more years you have to pay, so a total of 4 years. If the discount rate is 10%, so this discount rate is the nominal, so it's always nominal when they do it like this. What is the present value of the cost of this lease in nominal cash flow and in real cash flow? Okay, let's try to dissect this. Let's do nominal cash flow first. So hopefully immediately, can you tell that? Okay, I'm just going to draw the timeline here for you. 0, 1, 2, 3, 4. You are going to pay 8,000, right? Immediately. 8, 8, 8, 8. I hope everyone can see that it is a due situation, because your cash flow starts at the start of the year. Anyone has issues seeing this? And can you tell there's an ordinary due situation because you only have 4 cash flows, not infinite, right? So it is 4 cash flows and it starts at the beginning of the year. Okay, so recall your annuity due formula. However, do notice that it's a growing annuity. Why? Okay, I'm just going to flip back to the previous slide. can you see that the lease cost you 8,000, immediately increasing 3% a year. So your lease is going to increase because of your inflation, and therefore in nominal cash flow terms, nominal cash flow means that the cash flow without considering inflation, that amount of cash flow, that nominal amount must be bigger and bigger, right? In order to pay off the same lease amount, right? Because inflation is going to reduce your in the nominal sense so that it's equals to 8,000, right? So in nominal sense, your cash flow must get bigger and bigger so that you can still pay off $8,000 worth of lease payment in after considering for inflation. So in this sense, it is a growing annuity and a due case because it's at the back. Yeah, everyone can see it's a grow. Why is it growing? And annuity because it's 4 payments only, and due because it's a start. So it's a combination of all three. Growing, it's an annuity, and it's a due. So having identified it's a growing annuity due, we can use the formula. So I just plug in the values accordingly, and this is your inflation I here. Any questions for this? Now, this is in nominal cash flow terms. Let's look at real cash flow terms, because the question asks you, I'm just going to flip back to your question. What is the present value of the cost of lease in nominal cash flow and in real cash flow? So let's look at real cash flow now. So in real cash flow, what is the actual rate? So remember, just now the slides, I say when we are talking about real cash flow, we need to use real rates. We use nominal cash flow, we use nominal rates, right? So now we are going to talk about real cash flows. We're going to use real rates. So we calculate what's the real rate after considering inflation. So your rate actually is much lower, which makes sense, right? Because your real rate has been eaten up by inflation, right? It has eaten up your rates. So your real rate is lesser. Makes sense. In this sense, you just do an annuity due again because it starts at the start. And you get this. Now, for a annuity due situation, you can use Excel, right? I have put the Excel here. Make sure your type is 1. This is important. Type is 1. You can use Excel to do it. Remember, only the growing, where there's a grow function, you cannot use Excel. Do you notice something? By calculating the real cash flow using the real rate, you get this. And by calculating nominal cash flow using the nominal rate, you actually get the same answer because you have, in both cases, you have taken into account inflation in a different form, in a different way. In the nominal sense, you have taken it in form of a growth of your cash flow. In the real sense, in this real sense, you have taken it into account using the Fisher equation.
So sorry, got a bit lost between these two actually. I'm trying to see the formulas, right? So for the earlier formula, the one before this on the nominal cash flow, this is a growing annuity formula, or it's just a
Growing
normal
annuity.
So this growing annuity. So but I'm just wondering, you said we can't minus the real rate minus the nominal rate just like that, because it shows the growing annuity formula, it shows 10% minus 3%, right?
Yes.
So that is under the R minus the G. I guess the G is the 3% and R is your rate.
Yes, that's right.
Okay, so for the other one, is the formula the same or is it a different annuity formula?
So you mean this one, right? In the real form.
Yes, that's right.
So in the real form, you do not use growing annuity, you just use annuity due formula. So you do not use the growth function because you have considered the growth function in the Fisher equation, you have reduced the rate here.
Oh, okay, right. So you've already reduced it, and so you don't need use the growth, but the normal annuity formula.
Yes. And the
Right.
reason why two different methods giving the same answer is because in the second question, in this question here, the real cash flow, recall that when you want to find real cash flow, we need to use real rates. In the first question, they ask you for nominal cash flow, means that you need to use nominal rates, which is the 10%.
Okay, noted.
And consider the inflation in the sense of a growth factor. Right?
But both ways you get the same answer, right? So actually, or we have to do the correct formula based on the question asked, I guess.
Correct. You must use the correct formula based on the question asked. Because this one, they say they are very specific. What is the present value of the cost of the lease in nominal cash flow and in real cash flow? So they want you to show the two different methods, even though the answers
Right.
are the same.
Okay.
Yeah. Okay. So I think we have one more question here. Yes, we have one more question. Let's go through this question. Again, we are going to talk about inflation, real and nominal. So hopefully this will give you more clarity as well. So if you have reached 60 years with a modest fortune of 3 million, and are considering early retirement, the nominal interest rate is 10%, inflation is 5%. Okay. So how much can you spend each year for the next 30 years, assuming that your spending is stable in nominal terms? So what's happening here? Okay, let's just think before we do a calculation, right? Let's think about it. Okay, we have reached 60, we have 3 million. We have a nominal interest rate of 10%, but we know that inflation is going to eat our fortune, right? And the inflation is 5%, so it's going to eat our fortune. Now, the question is how much can you spend in stable nominal terms? Okay, so let's think about this. So I've kind of wrote the explanation, so it's easy when you do when you revise through your slides, right? So since spending is stable in nominal terms, it means that the spending amount is fixed yearly, right? It's stable, it's fixed in terms of nominal. But because of inflation, you can buy less and less product each year. Yeah, that makes sense, right, for everybody? Because yes, it's fixed in nominal. So so for example, every year you can spend 50K, but every year that 50K product that you can buy is lesser. Because this year you can buy 50K off product, but next year maybe you can buy 45K off product only because your inflation is eating away your money. Now, the question is say is stable in nominal terms. So when discounting actual dollar, remember use nominal discount rate. That's what I mentioned earlier. So we have 30 years. So the question is, I'm just going to flip back. You reach 60, you want to spend for next 30 years, right? So NPR is 30. Your present value is what you have now, 3 million. Your rate based on nominal rate is 10%. At the end of 30 years, you have used up all your money. Your FV is 0. Your type is 0 because it's just a normal case. Nothing, it's not due, the due, annuity due kind of case. So you calculate your payment as this, right? So this is how much you can spend in nominal terms. Okay, this is for part 1. Now, assuming, okay, so part 2 is the part that's interesting. Assuming your spending is stable in real terms, what is the amount you can withdraw? Sorry. What is the amount you can withdraw from the account in year 1 and year 30? Okay, so now you want your spending to be stable in real terms, means that you need to take into account inflation, right? So for example, what does question part 2 mean? It means that let's say I have 50K. I can spend 50K per year. Let's just say I have done a calculation. Let's say 50K per year. The idea is that this 50K, next year, I must be able to buy 50K of products as well. The following year, also 50K of products. meaning that I need to account for the inflation that's going to eat into my money. So let's think about it. What does this mean? It means that every year, in terms of nominal sense, you must you must be able to withdraw more money, right? For example, this year I withdraw 50K. Next year I must withdraw, let's say 55K, so that 5K is being eaten up by inflation so that I can still spend 50K on products. The following year, maybe I need to take out 60K and 10K is being eaten up by inflation so that I can still spend 50K. Everyone understand this part? What does this mean? Need me to repeat? Sorry, yes as in repeat or no? Okay, that's all right. Okay, so now we understand this, let's do the calculation. Because once you understand, then the numbers actually make sense now. Okay, so let's see. As usual, I have written down the explanation, so in case we revise, you can kind of understand. So stable spending in real terms means that you should maintain the similar quality of life. So that means if I want to take out 50K, I must be able to spend 50K worth of product today and 50K worth of product tomorrow, or in next year, etc. So when discounting constant dollar, use the real rate. Okay, so I use Fisher equation again. I'm using Fisher equation to calculate what is the real rate. Now, similarly, I have 30 years. The present value is 3 million. I have a rate of the real rate now of 4.76%. At the end of the 30 years, I have no more money. And I have a real stable payment PMT of this, right? Now, before, let's just flip back. Can you see that the amount here, let me use rate instead. Can you see the amount is lesser? Payment per period, this in nominal sense is so much at 318. However, in real sense, I can only get 189, which makes sense, right? Because every year we know that a portion is, even though we can draw more money, a portion has to be paid or account for inflation. It's going to eat away what we can spend, right? So what's happening now? So let's look back at the question. What's the question asking you for? What is the amount you can withdraw from the account in year 1 and in year 30? So in year 1, you just take this times 0.5, which this is the inflation, right? Inflation. So in year 30, you're going to withdraw a lot more money, right? 30 years later. However, the real spending power of your money you withdraw is only this 189K, right? So inflation is the last part. We have completed today's lecture. That's all actually I have. So last reminder, in fact, now it's already posted. You should see in your module tab under lecture recording, lecture 2B. And lecture 2B is basically more questions relating to the topics that we have talked about today. And it's a recorded lecture. It's mandatory to watch in the sense that it explains to you basically go through all the questions. I think we have 20 over questions. It goes through step by step how to get them. However, if you want to challenge yourself, I encourage you to first practice the question. There's written answers there already. If you don't need to watch, if you are able to do the questions, you don't need more explanation. You don't have to watch the lecture. However, I encourage you to watch it if you feel that you want more revision on the concepts. Okay, so that's all. Any questions so far on time value of money? So that's all we have for time value of money. next lessons we'll cover other things. Training, yeah, it's so time value of money is very important because it's the foundation to your other lectures. It is a lot of calculation, which is why for time value of money you really need to practice more questions, and that's why we have lots of self-review questions here. For the self-review questions, there are no lecture recording. However, answers are provided to you. As such, if you do have any issues trying to get the solutions, you can drop me an email. Usually I reply email really quickly, but I have provided you all the solutions as well. So those of you who have downloaded the slides 2 weeks ago, there are no solutions, but if you download the slides now, solutions are provided. And also go through the lecture 2B set of notes as well as the lecture. Yeah.
So can I just ask a quick question? With regards to, I think I'm just wondering in the Excel, right? When you use the formulas, what do you use as a gauge to see whether you use a PV or a payment or a FV formula?
So based on the question, like what the question is asking for. So like if the question is asking for, in this case, the inflation case, because they're asking for what is the amount you withdraw for each year, right? So that's like payment. So it's based on the question, if that makes sense.
Okay, so if they're asking for a future value, then you use a FV formula. If they're asking you for a present value, then you use a PV value. Can I say that generally that works?
Yeah. Or if they're asking you for rate, they use the rate formula.
Rate formula, right? Okay. All right. Thank you.
Is the TMA covered lecture 1 to 2 or 1 to 3? Good question. Let me just check. I can't recall. I think we went through it at the start. 1 to 3. So TMA is 1 to 3, as mentioned in your slides here. Yeah, so it's due on 8th of March, so we do still have time. Usually it's after lecture 3. As in now you can start doing your TMA, but the portion that we haven't covered is lecture 3, so you can stop your TMA at that question that has not been covered, and then in lecture 3 we will you will be able to do that last question. Yes, and I will go through the TMA after they are being marked and released. So usually, of course, because we have quite a few tutorial groups, so we need to make sure that all the tutorial groups have all the students have submitted TMA. Then we will usually release the results and go through the questions together. Okay, let me just pause the recording.